When we talk about the U.S. electric grid, we're referring to the large high-voltage power lines used to deliver bulk power, as well as the hardware that links them together. The U.S. has over 160,000 miles of transmission lines. They move electricity from power plants to cities and towns, and from one part of the system to another. The grid's designed so that if demand goes up in one location, or a major transmission line or other electrical infrastructure goes down due to weather, a technical malfunction, or even a terrorist attack, power can be rerouted to prevent blackouts. But it's not always effective, as the big 2003 blackout in the Eastern Interconnection demonstrated when 50 million people lost power. Is it just one big grid? Not quite. Actually, it's three grids, also called interconnections: the Western, the Eastern, and the Texas interconnection. While plenty of power transfer goes on within each of the three interconnections, there's not much ability to move power between them. In a pinch, California, for instance, couldn't rescue New York. On this map of the grid, the blue lines are high-voltage, direct current lines able to carry bulk power across long distances. In the West, for example, they help supply Southern California with electricity from the Pacific Northwest in the summer, and power flows reverse in the winter. DC power has to go through conversion stations before transferring to AC, alternating current lines. High-capacity AC lines, the red and dark orange lines on the map, link areas like the Midwest, the Eastern Seaboard, and the Southern U.S. One challenge for today's grid: the highest transmission lines don't reach some of the newer renewable sources coming online, like wind and solar, because they often are in remote locations. What are substations for? They're essential. When power leaves a generating plant, it usually goes to a step-up substation to increase the voltage before the electricity can ride the high-voltage transmission lines. But before that power can get to end users, it must go through another substation that brings the voltage back down again. Some industrial facilities can handle this level, but for homes and offices, the electricity must pass through a separate distribution system with its own substations. That brings the voltage down even further. It's reduced a final time on those transformers you see on electrical poles, delivering the 120 to 240 volts you get from a wall socket. What causes blackouts and brownouts? The system has redundancy built into it, but if demand increases too quickly and there aren't enough power plants online to ramp up production, grid operators usually order rolling blackouts until the system gets back in balance. Also, if too many high-capacity transmission lines or transmission substations go down at once, for whatever reason, the system or parts of it could be overwhelmed and fail. That's the short answer.